Welcome to the Real Python Podcast. This is episode 237. What goes into creating automated tests for your Python code? Should you focus on testing the individual code sections or how the entire system runs? Christopher Trudeau is back on the show this week, bringing another batch of PyCoders Weekly articles and projects. We discuss a recent article from Semaphore about unit testing versus integration testing. Christopher shares his experiences setting up automated tests for his own smaller projects. He also answers questions about building tests in an existing code base and integrating tests across systems. We also have several other articles and projects from the Python community, including a news roundup, improving default line charts to journal quality infographics. Why is hash -1 equal to hash -2 in Python? Data cleaning and data science. Ways to work with large files in Python, a lightweight CLI viewer for log files, and a tool for mocking the datetime module for testing. This episode is sponsored by Postman. Postman is the world's leading API collaboration platform, and they just launched Postman AI Agent Builder, the quickest way to build AI agents. Start building at postman.com/podcast/Python. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher.
Hey there.
Welcome back. We're diving in to some more Python goodness this week, another PyCoders episode. So you got a whole bunch of news stacked up here.
Yeah, whackloads of news.
I haven't heard that term. All right. You want to dig in?
Sure. Starts out with Python's Py release 3.14. It's hit Alpha 4. And then we very quickly move on to more release stuff. Django has Alpha 1 of 5.2 has come out, as well as issued security releases, which gives us 5.1.5, 5.0.11, and 4.2.18. Primary purpose of those security releases were a potential denial of service vulnerability in IPv6 validation. So if you're using IP addresses in forms, you should definitely update. The scientific library SciPy has released version 1.15. This version contains a whole bunch of improvements to sparse arrays, enough so that they're recommending sparse arrays over sparse matrices now. It also includes preliminary support for free-threaded Python 3.13, which is great. Scientific number crunching is one of those places where concurrency might be helpful. So the fact that the big libraries are working on this is good. My favorite coloring book, Pigments, has released 2.19. which includes 11 new lexers, updates to 19 existing lexers, and a boatload of bug fixes. And on top of all the release goodness, PyConf Hyderabad has been announced for February 22nd and 23rd. Gotta love a city with almost 10 million people, and it's still only the 6th largest in India. So if you're nearby and you're a Python person, check it out.
Yeah, cool. All right. Lots of releases, lots of stuff for people to dig into there. We have a variety of topics this week. I'm kind of going down a bit of a data science route. And my first one is about, I'll just read the title, From Default Line Charts to Journal Quality Infographics. And this is a Towards Data Science post on Medium by Vladimir Zhivov. The title mostly explains it. Matplotlib has defaults that, you could call them pretty Spartan, or you might call them ugly, depending on your opinion on that. The piece takes you step by step into prettifying this sort of standard output. In this case, they're using a line chart as an example. Many of the things that are covered in it, I've talked about before being covered and maybe stored inside what's called the style sheet. And so I'll include some links to some materials on that. And I've talked about that in the past, but that's a good way to give you a kick in the right direction as far as like making things look a little better than the standard output or more in your own style that you can develop. Many things that are shown are, again, they kind of get you pretty far along the path before you have to dig into every individual level of change. So in this particular one, there are code examples throughout, which is nice, little code pieces. And you start by making these needed imports, bringing in pandas and NumPy, but individual areas inside Matplotlib, you're going to be bringing in stuff for dates and tickers and different parameters. So it's good just to kind of look at that to kind of get an idea of where in the library you're going to be working. You generate some sample data. This alone is a good practice thing, if you're doing data science stuff or, getting beginner or intermediate there. That's something I always enjoy, learning different ways to generate some sample data for you to play around with. The goals in this particular exercise is to fix the title, set some chart parameters for the size, and changing the y-axis so the ticks are to the right, which can be really helpful, especially if your data kind of leans more to the right, or you want to format other kind of explanatory stuff on the left or above. You're changing the main lines, color and style and width. And again, providing the code for each of these as it goes along. You're adding a minimalistic grid to the background, removing borders for a cleaner look, and then removing ticks from the y-axis also because you have that nice grid that you're putting in there. So a few other aesthetics. Finally, a really interesting trick of generating a gradient, which is all done in code. In this case, you're taking a dark green and moving to more transparency on the bottom. It actually makes it look a lot like stuff you might see, like, again, in a publication. In this, they're using a clipping technique along the path of the line. This is not something that you can add via style sheet, but you could probably do it with some reusable code that you could then put into other, things if you're doing common line charts and things like that. There are some suggestions on how to fix it up and beautify it a little bit more. In this, he's using like an image tool. He's using Google Slides, which I think is interesting. I think this is where maybe if you wanted to stay in Python, you might use something like Great Tables and maybe embed it inside of a table because it has a lot of prettifying tools that kind of are aligned in that way. So maybe check that out for text and formatting. Shout out to my previous episode on that. And then I have another resource I wanted to talk about briefly. I like sharing these things where it's a collection. People have gathered a large amount of, in this case, Python tools for data visualization. And this site is called PyVis. And it's an overview of all these different libraries across the Python ecosystem. And if you're trying to pick a tool, it's a really great place to understand pros and cons of each. It has suggested collections, examples, tutorials, areas for specifically if you want to do dashboarding, what libraries kind of work well for that. Topic examples, which I think is interesting. So if you're in a particular domain, field, or do a type of research, then there might be types of graphs and charts and things that you would do often there and visualizations that work well. Actually, I found another site that's similar. It's called pythoncharts.com, python-charts.com, and that has that section about Matplotlib style sheets. And if you'd like to learn a little bit more about those, it also has advice about other topics and tools like Seaborn, Plotly, color palettes, and sort of color theory, which I think is important if you're doing a lot of that. I featured a reference to another site, in episode 125 about Matplotlib. And one thing that, just a reminder as a tool, the Wayback Machine is still out there in case sites disappear and you want to go look for it. So I'm going to include a link with the web archive for this one that's about the magic of Matplotlib style sheets. So just to sort of refresh it for you. But yeah, so a whole bunch of visualization goodness for you this week.
That gradient trick is pretty cool. It made a big difference in that graph. It went from sort of looking like, oh, I did this in Excel to, oh, I had an artist do this. So yeah, it's something to put in the armory for future use there.
Yeah. I could see you using it to clip other things like in different bars of a chart or things like that too. So yeah, cool. What's your first one here?
My first article this week is by Omar Majid. He's a fellow Torontonian. I found that out after I picked the article, in case anybody wants to claim bias. The article is titled, Why is #1 equal to #2 in Python? So the post starts out with the phrase, while browsing Reddit the other day, strike that, while waiting for my code to compile, Omar came across a thread in our Python asking if the fact that #1 equals #2 is an Easter egg. So if you're not familiar, A hash function is one that takes a value and converts it to a number. This is used in dictionaries, also known as hash maps, to create a quick lookup mechanism based on the key in your key value pair that gets added to the dict. So Python has a built-in function called hash that performs this operation, and it's what the underlying dictionary mechanism uses. Hash values aren't guaranteed to be unique, but the fewer things that map to the same number, the faster your dict lookup is going to be. So when two things hash to the same value, this is called collision, and collisions mean extra code getting triggered underneath. All right, so in the REPL, you can call hash with any hashable object and you will get back a number. For most random things, you're going to get different numbers, but for some reason, hashing -1 and -2 both give the result of -2. Like Omar, I was kind of surprised by this, and my first instinct was this might have something to do with the fact that small integers in Python are handled in a special way behind the scenes, but that's wrong. #0, #3, #-4, he tries all these things and they all give different values, so that wasn't the reason why.
Okay.
So to get to the bottom of the mystery, Omar dug into the CPython source code, and to be specific, this only happens in CPython. It's a CPython thing rather than a general Python thing. And he did something kind of clever to find the code in question. He ran help on the hash function and then grepped for that part of the help message in the C code rather than trying to figure out where these things are. And it like popped up in 3 places, and 2 of them it was obvious that that wasn't code, and it was like, oh, there we are, built-in module.c. And he found the function called built-in hash, which inside of it has an object called PyObjectHash. Then he grepped around for that, and that's where he found the answer. So it's quite common in C to return -1 to indicate that something went wrong, which means if your hash calculation results in -1, you can't return it. So there's actually special code for this case, bumping the hash result of -1 down to -2. So this, boys and girls, is one of the arguments for using try-except blocks, because in-band signaling can always conflict with real results. The North American phone system learned this the hard way with a lot of free long distance until they changed it. Google Captain Crunch and freaking, spelt with a PH, to learn more about why this is not the right way to do your signaling.
I didn't know it was related to that. That's great.
It's a loose relation. Anytime you have the same thing delivering your signal is the thing you use to control the signal, someone can change the signal to screw with your controls. So
or figure out what that signal is as far as sound. Yeah,
exactly.
All right. Postman is the world's leading API collaboration platform. Trusted by over 35 million developers and 500,000 organizations worldwide. They just launched Postman AI Agent Builder, the quickest way to build AI agents. With centralized access to the latest LLMs and APIs from over 1,800 companies, plus no-code workflows, you can quickly connect critical tools and build multi-step agents, all without writing a single line of code. Start building smarter agents today with Postman. Visit postman.com/podcast/Python today. That's postman.com/podcast/Python. My next one, again, staying on my data science theme here. This is from Helen Scott on the JetBrains blog. So quick caveat, it mentions their tools and using some of their new AI features. I'm sure they're promoting that stuff quite a bit. But it's part of a series. Actually, I think the series might be useful to dig through all of it if you're interested. The first is something that comes up often when talking to people about data science is like, well, where can you find good data for working in data science projects? And it has several good sources, ones that you might be familiar with, Kaggle, and then some other ones you might not be so familiar with, a couple different repositories out there. And getting good data is always useful, and or actually maybe interesting data too. So, and then typically local government stuff is also another good resource. I talked to a couple of people recently about that. So that's the first of the series. The second in the series is data exploration with pandas. So in this one, typically this is a step before this article I'm talking about this week, which is, before getting to cleaning, this is where you would actually sort of push data around and look at it and try to see what is the story we're trying to tell here, what's interesting about this data set, and so forth, sort of exploring it and a variety of tools and techniques that are inside there. So in this article, again, if you're following along, It uses the same data set, which is about housing data. It says the Ames housing data set, and Ames, I'm guessing, is Ames, Iowa. That's the only other place I've ever seen that name, AMES. It starts with a very good introduction about why is data cleaning important, and then dives pretty deep into a variety of examples of data cleaning and ways to do that. In this case, it's very pandas focused. So they start off with deduplicating data and using methods that are built into pandas, the dot drop underscore duplicates, how to deal with implausible values. So looking, again, this is something you might figure out using summary statistics, stuff that you might have figured out in the data exploration area, where you might, again, flag stuff for the future to say, okay, this is stuff that needs to be cleaned. Implausible values, that might be something that was fat fingered in a survey, or some other kind of messy data appeared there, and stuff that doesn't fit inside the data set. Not necessarily an outlier, but actually stuff that just looks like foreign. It doesn't look like it doesn't belongs in this data set at all, and what you want to think about doing with that. And so it talks about the drop method from pandas. Formatting the data, then, this is like rounding values, getting uniformity, probably thinking about the data types for your columns and making sure that everything conforms to that before you build that. And then addressing outliers and looking for missing values. This is a really interesting section of this whole piece. It talks about different types of missingness. Is a pretty good made up word. Missing at random. Okay, so this is like faults in how a survey in this case was done. So maybe you have a variety of people that are doing the canvassing for this data, and they present the questions differently, or they decide to skip over something because it's not important. So maybe there's random reasons that data is missing there. And there's a good quote: if you understand the pattern behind the missing data, you can often use contextual information to impute the values, which ensures that relationships between data in your data set are preserved. So this is where you might actually do something to replace those values that makes sense to keep them within the ballpark and imputing them. I always scratch my head at that one as far as like, do you really want to add values just to add values? But I guess it depends on the research that you're doing. The other missingness is missing not at random. So these are things that just were not reported. Again, in the survey, this is about homes. And so like a seller of a home might selectively omit things, choose to not enter that data into a survey. There's one interesting example they have in this where you're looking at the lot that a home sits on. And so the frontage of the lot, depending on where the home's positioned in the lot, they might ignore it if it's really small. Like it makes no sense to enter a value in there because they're like, well, it just abuts the sidewalk or what have you, or something like that. So a smaller lot frontages are less likely to be reported in that particular case. So the meaning of the missingness is directly related to the missing value in that one. So interesting couple paragraphs there talking about the theory of that. And then all of these kind of lead to this short code example of visualizing the missingness. And in this case, they give you some code to work through of building a heat map to look at trends and areas where this is kind of across the board. And again, ways to deal with it. So again, I feel like it's a bit of data exploration still in here as opposed to just purely cleaning it. So I like the article. It's a good piece. I think it's a good series to kind of get you into this stuff. There was another article I was going to maybe talk about this week, and it talked about automating these techniques. And unfortunately, it wasn't really as much about automating as opposed to like kind of manually building some functions and doing some other stuff around it. I did find this other library, and I might pull it for a project later when I have a chance to play with it a little bit more. It's called Pandera. It's an open source framework for precision data testing, but it has a lot of actual automated methodology for going through the data and looking for stuff and trying to speed up the process of cleaning your data. It looks like a very powerful library. So that one's called Pandera. So I'll include a link to it as something for further study. What do you got next?
My next article is 10 Ways to Work with Large Files in Python. It's by Alexei Anakov. It's subtitled Effortlessly Handle Gigabytes of Data. This listicle style article covers a bunch of different things you can do when you've got a lot of data and starts out by giving examples of when you might need these techniques. Data science world is filled with this kind of stuff. You might be frequently crunching things that are just too big for memory. And likewise, machine learning bumps into this problem a lot as well, as often the training data sets are pretty big. Most of these techniques are mechanisms for not reading everything into memory at a single time, so parsing and processing parts of a file as you go along. And of course, this avoids the running out of memory problem altogether, or hopefully. And sometimes it's faster. That depends on a whole bunch of things that we're not going to get into. The first two of the 10 techniques are related, basically using simple for loops to read the contents of a file. The first technique reads items in a line at a time, while the second uses chunks. The file read method takes an optional parameter where you can specify the chunk size. And so this allows you to say, I want, this many bytes of data as I go along. The next technique adds an argument to the file open call, which specifies buffering. This argument takes the size of a buffer and when set correctly can reduce the number of disk I/O operations required to read in a given file. And again, gives you kind of that chunky thing going on. Number 4 on the list is to use the mmap module. This maps a file to a byte array in memory, giving you random access to parts of the file. For details on this technique, we've actually got a tutorial and video course on this one at RealPython. We'll provide links in the show notes. Techniques 5 and 6 build on that line or chunk at a time idea and then mixes them in with generators, allowing you to abstract away some of this kind of file access. The remaining techniques are library specific, covering how to stream data from a URL using the request library, how to use Dask or PySpark for parallel processing. And finally, there's a small list of libraries that are specific to certain file formats for things like JSON, XML, and Parquet. And all in all, this is a good list and worth taking a read through if you're starting to play with larger data sets. I'd add one more that he missed. Polars does this very well. It comes with a set of file reading functions called scan. You can scan, say, a CSV, a JSON, or an Excel, and there's others as well. And then you can create what's called a lazy frame. The lazy frames optimize your queries. Say you want to do a calculation on a subset of your data, the lazy frame will filter it first, reducing what needs to be in memory for the calc. So Polars has got a strong advantage over Pandas and some of its relatives because of some of these large file features. So, yeah, article's worth checking out, and there's some neat little libraries in here. So go figure this stuff out.
I really enjoy that about Polars. I think it's one of the more powerful things. There's a lot of quote unquote lazy stuff that's done inside there that not only lets you deal with having a machine that maybe doesn't have that kind of amount of memory. And that was one of the funnier things about talking to Simon Willison last week is he's like talking about using these LLMs locally and, being able to run one on his machine and how like the first bunches of them were kind of crazy in size. And then I kind of tried to poke fun at him, but he seemed like, this was like a regular thing that he had 64 gigabytes of RAM in his laptop.
Right.
And I'm like, yeah, that's an unusual amount for an average individual user. But I guess somebody, again, doing lots of data work might have more than that. I don't know. What's the most RAM you've had on a machine?
I don't know. I don't know if I know the answer to that question.
I think 32 gigs is probably the most. I had a workstation that had 128. So.
Yeah, if you're talking about if you're including workstations, I have had access to 128 gigabyte boxes.
Yeah, that was mine. Yeah.
So
I'm like, wow.
Yeah.
Yeah. So we decided to have a discussion this week regarding testing, since you have a lot more experience having some background, not only going to school and covering some of these things, but also working with teams. I thought we could do this as a little bit where I can ask you some questions about it, which I think will be fun.
Sure.
You ready to dig in?
Yeah, so we're basing this on an article that we posted called Unit Testing versus Integration Testing, Test Automation Basics by Federico Trotta. This is a pretty comprehensive article, and it's actually quite lengthy. It covers why you should do automated tests and what a lot of the common terminology means. I'll start out a bit with the why. The obvious, which is it tends to improve code quality, and it means there's fewer errors. The more tests you have, the more likely you are to catch bugs. The second big win tends to be faster delivery. Manual tests, especially if they're going to be comprehensive, take a lot of time, so automating this process reduces that significantly. They actually don't talk about one of my favorite reasons, though. which is the safety net. Developers, when you've got a good comprehensive set of tests, developers are more free to experiment in the code if they know there's a good set of tests. So say you've got an idea to speed up a particularly gnarly chunk of code, but you're afraid to break it. Well, if you've got comprehensive tests, then you'll know if you broke it. And this kind of safety net tends to drive higher quality code, not just because you've got tests for it, but also because programmers are more likely to dive into the things that are crufty and not be worried about breaking it and, causing the system to fall over.
Yeah.
And this means you end up having developers being more likely to get rid of crufty code because they're assured that they aren't going to accidentally break something.
They're willing to try things.
Exactly. Yeah. And I think that's a superpower, and it's very, very helpful for the long-term productivity of development teams. The article goes on to explain the concept of a unit test versus an integration test. Note that these terms are very, very loosely defined, and what some folks might consider a unit test, others might consider an integration test. And this is made messier by the fact that most testing libraries refer to their chunks as unit test classes or methods, even though you might be using those things that they are calling a unit test to write an integration test. So the vocabulary here is all over the shop.
Yeah, okay.
Messiness aside, a unit test typically revolves around a single thing. In the article, they call it the smallest testable piece of software. This often means a single function or method in your code. By contrast, integration tests start to glue these kinds of components together and operate at a higher level. Again, this is where the vocab gets messy, as some people will make a distinction between integration and system tests. And without getting into behavioral-driven tests or GUI testing, which just makes it that much more complicated, and nobody uses these terms consistently. So it's all over the shop.
Okay.
So it's best practice to build unit tests based on the FIRST acronym, and they talk about this in the article. F in FIRST is for fast. You don't want to be staring at the unit tests while they run forever. The longer they take, the less likely your coders are going to run them. I in FIRST is independent. Unit tests should be able to be run in any order without changing the results. R is repeatable, meaning you should be able to run it over and over again to get the same answer. S is self-validating. This means it should be clear whether a test passes or fails. This is typically done with assertion statements, something like assert equal my result and 42. And then last, the T in FIRST is for timely. This means you should be writing them as close to when you're writing the code as possible. So don't go write 3 million lines of code and then go, let's add the tests. So in fact, there's a whole philosophy known as test-driven development that believes that you should write the tests even before you write the code. We can talk about that and what I think about it if you like.
Sure.
We're still not quite through the article. There's a whole bunch here.
Yeah.
So integration tests often and sometimes can't implement all of these objectives for FIRST. For example, if your system has to cause a transaction to happen, there might be a before and an after the transaction. So now FIRST is still a good idea, and I much prefer to work in code bases where this applies even at the integration level, but lots of legacy code bases can't do this. And it can get kind of ugly when you're testing code that is interacting with internal systems. So I used to work at a gambling company, and we had 2 programmers who were dedicated to writing bridge code to financial institutions. So when the US made gambling over the internet quasi-illegal, a whole bunch of workarounds started to pop up. And some of them were as simple as, let's talk to a bank that has no business in the US. And others got kind of janky, like using prepaid phone cards as if they were currency. Yeah. So some of these financial institutions provided full working simulations for testing. And with these, you could clean up your tests after it was done, allowing you to embrace the independent part of FIRST. Other institutions would let you use the production environments, but only for a specific account, and they'd zero it out when they were done. And others would require you to set a flag in your test calls. So in both of these last 2, you've got no control. And so your integration tests can't all implement the first principle because that last transaction's still in the system and you aren't in control to wipe it out to fix that.
Yeah.
So anyhow, the article goes on to give specifics on how to set this stuff up, including a sample application, sample test to go with it.
Yeah, all done in Flask, right?
Yeah. And I seem to recall you saying this was a discussion part of the podcast. So maybe I should let you get a word in.
Well, I guess some of this, I think this has come up a couple times where does this come up in university classes that you took? This idea of testing and unit versus integration?
when I part of it's a slightly unfair question because I went to school at the dawn of time.
Right.
So it was starting to pop up as specialty courses.
The internet was not as prevalent.
Yeah. I did a software specialty in my degree, which meant I took a whole bunch of courses that were specific to software stuff. And one of those courses was like testing and managing code and that kind of stuff.
Okay.
But to give you context, I was in the first class to go through this. So they were still setting it up in the 90s. So
do you think it's still common? Like, you think
it's becoming more common.
Okay.
That being said, there have been some students that I have mentored recently who have like academic knowledge of it, and that's it, because it isn't necessarily pushed.
That's what I was wondering, like the emphasis on it.
A buddy of mine had a few interns, and my buddy was non-technical, and he's like, could I have you just like talk to them for a little bit and like help them out a little bit? And so like I spent a little bit of time every once in a while, just sort of act as that sort of mentor thing. And it was like 4 or 5 months later, he's like, I don't know what you did, but it was fantastic. And I'm like, all I really did was thou shalt have unit tests and thou shalt have CI/CD. Now go. So it's not like it was a big deal. But so they
it wasn't like the documentary Scared Straight or something like that, where you took the kids to prison.
They had the concepts, they'd heard of it. It's not like they went, oh, what is this stuff? Yeah. But university projects, you're almost always doing toys. And so unless the prof is like hardcore about this, they're not likely to go write 100 lines of code, now go write 100 more that tests it to prove that it works. So it's there, but it's not, they're not necessarily religious about it.
Okay. One of the things I thought about is in your own personal experience, because you have I talked about this with Simon quite a bit. He has like 180 like personal projects on GitHub and some of them on PyPI, just various things. And it becomes like this repository for him and so forth. When you make these smaller libraries, is there testing in them or like say like a CLI library or something like that? Do you go beyond print and so forth?
Yeah, so a lot of it depends on the library. So if I'm building a utility library that I know I'm going to be reusing, I tend to be anal retentive about my coverage.
Okay.
So Django All, AWL, is one of my sort of go-to utilities. It's got the crap in it that I always go, I need these 3 lines every single time I do Django, so it's in there. I have 100% code coverage on it. Okay. Now, that doesn't mean it's working. 100% code coverage doesn't guarantee correctness. Okay. But because I know I'm going to be reusing it and there's a high chance of, something breaking from version to version, there's a high code coverage on it. Using the vocab they are using in the article, there's really no integration testing in it because it really is just that functional level. If you talk about something like the utility that we use to do screen shows to make it look like we're coding on live while we're recording. Yeah. The Purdy library, testing GUI stuff, even terminal GUI stuff, is brutally hard because you usually need an outside actor to validate how, like I push the arrow key and something's supposed to change on the screen. So I need an outside actor to look at that. And that tends to be getting into sort of the integration test.
Hard to automate. You have to kind of manually do it.
It's possible, but it's another level more difficult. Okay. So Purdy, I've got tests that are like down at the unit level, but I've only got like 60 or 70% coverage in that library because I've done some hackish things to test some of the TUI pieces, but otherwise I haven't. And in fact, I've got an ongoing side project, and I think we're into year 2 of it because it's like I should try that again, and I just never get around to doing it. But I'm trying to port it from the current TUI library that I'm using to a different TUI library, and one of the drivers behind that is because Schematics, which is where I want to put it to, has a great TUI testing mechanism built into it.
Oh, okay.
And so it'll allow me to get a much higher degree of coverage out of it because he's got a concept in it, which is basically as the TUI animation's happening, you can say, I want frame number 3 of the animation and I want to compare it, basically dump the frame into a string. And then you can go compare that, do an assert of that against what it's supposed to look like.
So the hooks for testing are there.
Yeah. So you could basically save a bunch of screens, run through, and then you could go repeat and go.
Okay.
And in fact, just to swing it back to pigments, they've done a really, really good job inside of their unit testing mechanisms. They basically have a way of specifying a data file a series of data files. And one of them would be the thing that's about to get parsed and managed by the Lexer. And then another would be the expected result. And if you name the files correctly, their unit test hook automatically goes, okay, run the Lexer, put this data in, compare it against that output, and then make sure that it works. And the beautiful thing about this is if you make a change to the code that's going to change the output, you can essentially just save the output in the file, eyeball that it's correct, and then you don't have to write code that validates all this because it just becomes a straight string comparison, right?
So that makes you lean toward, if you're going to, use libraries in your own work, import these things, does that make you lean toward ones that have testing hooks and things like that, that kind of make it a little easier on your part to add the testing?
I think it really depends because sometimes you're interfacing with this stuff and sometimes you're not, right? Sometimes you're calling down into the library and you just cross your fingers that they've done the right thing.
Yeah.
It's not like I run their unit tests inside of my suite.
Yeah. Okay.
Although in larger projects, you might want to do that if you're trying to figure out, like if you're upgrading from Django 4 to Django 5 or something like that, there might be reasons to do that. But typically, you're just checking your own code and crossing your fingers that the stuff underneath is still working.
This week, I want to shine a spotlight on another Real Python video course. It covers a topic we touch on this week, which is a common next step for intermediate developers, beginning to test your Python code. It's titled Testing Your Code with PyTest. It's based on a Real Python article by previous guest Dane Hillard. And in the course, my co-host Christopher Trudeau shows you what are the benefits PyTest offers, how to ensure your tests are stateless, how to make repetitious tests more comprehensible, how to run subtests of tests by name or custom groups, how to create and maintain reusable testing utilities. Testing your code brings a wide variety of benefits. It increases your confidence that the code behaves as you expect and ensures that changes to your code won't cause regressions. This course is a quick way to get up to speed with PyTest, one of the best tools you can use to boost your testing productivity. Real Python video courses are broken into easily consumable sections, and where needed include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. It's interesting because I had a question I was thinking about, like how granular that you get with your own personal projects and how that varies with, say, a client or a big team kind of project. Would you say it depends again, like kind of depends on the project?
Yeah. Unfortunately, the answer to that is how legacy is their code base.
Okay.
And how anal retentive were the people who built it. So I've had clients where they've had almost no testing whatsoever, and it was always a nightmare to ship, and shipping would only happen once or twice a year because it would take 3 or 4 weeks for a large cadre of people to do manual testing on it. And if you've already got several million lines of code, creating tests for that is hard. It takes a long time, right? And there's things you can do about that, right? So one of my favorite tricks for that is you can run queries inside of Git that basically say, give me the modules, give me the files that have been touched the most in, like, say, the last year.
This needs a test.
And those would be the things you test first because they're the most unstable parts of the code. If you've got something that was written 10 years ago and no one's ever touched it and that's probably stable, the likelihood it's got a bug in it is much smaller because you probably would have encountered it over those 10 years. So if you're trying to bootstrap I've got a million lines of code now, where do I start writing tests?
Start here.
Start with the stuff that's unstable.
Yeah.
And then the other thing that I like to do with that is get the teams to institute a coverage rule for at least the new code. So yeah, you've got 3 million lines of code and the business isn't going to stop and let you spend 6 months writing tests for all of it. But you can stop digging the hole, and all new code must. So if you touch the module, it's not allowed to be checked in unless it's got 80% coverage. And so if you have to go and make a change, then you're going to start using that time to sort of add these tests so that eventually you'll get to a place where you've got it.
You're twisting people's arms, but in a good way.
Yeah. So eventually you'll get to a quality place.
Yeah.
And there's a business challenge with this as well. So a good rule of thumb, and someone's going to yell at this in the comments, but a common rule of thumb, let's leave the good for separate, but
sure.
A common rule of thumb is there's about 1-to-1 in the amount of code versus the amount of tests. So if you're writing 100 lines of code, you're going to have to write about 100 lines of tests. And so if your business is used to you delivering 1,000 lines of code a week, you now have to start writing 1,000 lines of tests to go with that, which means you're not going to write twice as much code. So now what you're doing is delivering 500 lines of feature and 500 lines of tests. And the business thinks your productivity just dropped by half because now you're delivering half as many features in the same amount of time. Long term, this is a good thing because your quality goes up.
Yeah, that's not a great metric. Yeah, it's not the metric they should be measuring, but
and what'll happen is, it can actually save the business money because it means they can spend less on manual QA and a whole bunch of other things.
And you got automated now. So,
but it doesn't mean you don't get into an argument. Yeah.
What's your opinion on the idea that they put into this article of tests act as documentation? Do you feel that that's true?
It is. I'm much more likely to believe the unit tests than I am any piece of paper anybody gives me.
Okay.
Because that piece of paper, 1, may not have been implemented properly in the first place. 2, might be way out of date. Whereas the unit tests, I can run them. And if they pass, then I know, okay, so now I can read it. And to take a simple version of it, right? If you're doing a unit test on something like a mathematical function like sine, you've got some numbers going in, you've got some numbers going out. Well, the tests that go with it give you an idea of how this is working, right? Like I've got data coming in, I got data coming out, and it's working. And so there's a certain amount of value to that. And in fact, I've read articles in the past with folks who've dealt with very large legacy code bases where like it was dumped in their lap and no one understands any of it. And hey, we need to add a new feature. One approach I've seen people take is start adding unit tests first, like spend a few weeks adding some unit tests, using that to help you understand the code, then start adding the new feature. So it can make a big difference.
So the thing that they kind of move into with integration testing being like a flow, right? This workflow of going through things. You already mentioned kind of an example with the gambling sites of tests that are kind of hard to repeat because they involve other systems and so forth, and having external resources like accounts or card numbers or other things that need to be involved in there. Do you have other examples of like tests that are kind of hard to repeat or output a variety of results?
Yeah, it almost always gets complicated as soon as you've got multiple code bases involved.
Okay.
And so if this program has to talk to that program, well, if you want to write a test for that, you've got 2 choices. You can either fake out to that other program, so mock it out somehow.
Yeah.
Or you can actually set up a test environment where both of those things are running and write some code that sort of overlaps between them, right? And to a certain extent, like if you look at testing tools like Selenium that are code runners, right? So these are used on the web.
Right.
It's pretending to click links, that kind of thing.
Right. Automating the human clicking of stuff.
Yeah. And to a certain extent, it's doing that, right? Because it's doing something to the browser, which may or may not trigger some JavaScript in the browser, which may or may not send something to the business logic in the middle, say your Django Python server, which then may or may not do something down to the database and may trigger things like stored SQL in the database, and then all that stuff has to flow back up, right? So tools like Selenium tend to be very, very top down, and there could be something going wrong at any one of those levels. And because those systems are interacting with each other, there's a chance that it isn't repeatable, which is that, again, that's that R in first, right? Yeah. And in fact, I've seen with large legacy code bases, what will often happen is like once a month, we're going to go and grab the data out of production and we'll bring it into the test environment and then we'll run our tests. One of the clients I was working with, just in order for them to test something, they would need, this was like an application process where like you submit a PDF and then there was a whole bunch of automation on the back end to say, did they submit the right information? Do they follow these governmental rules? All the rest of this. This was a huge multi-step process.
Right.
And the testers would actually go into the production data, look for a client that was currently in that state, and then start their manual test at that state. So there was like...
Use them as the golden child.
They didn't even have a way of creating the thing. And because it could take a long time to get to that stage in the process, they wouldn't want to start from scratch. So they would rather go sort of diving in the data to try to see what was there. And one of the things we started trying to work on with them was we started creating macro tools that would create a new application at the level of the process they wanted. So they could say, I want an application in step 5, push a button and get that inserted into the system so that they didn't have to go looking for stuff, right?
Okay.
But even that is really just sort of giving hacky, semi-automated ways to give them better manual testing, right? So
it makes me think about this other question I was kind of playing with, this idea of like, how do you limit the results? A lot of unit testing is very much of a binary kind of result that you want to get out of it, true false kind of thing.
Yep.
Are there techniques in integration testing that help you limit the results that you're going to get out of it?
Ideally, if you can, you want to be able to apply the same principles at the integration system GUI level as you do down at the unit testing. With existing code bases that don't have tests yet, that might become difficult to do, and you've got sort of that legacy retro kind of problem. If you're starting from scratch, there's ways of designing your architecture so that most of the time you don't cause yourself to have that problem. But there's lots of code bases out there that definitely do have the problem.
Yeah.
One of the things you sort of want to get down to, and again, this comes back to the F in first, is a speed, and related to that is a cost thing. So a common way of thinking about this is referred to as the testing pyramid. You'll find if you Google that there's 3-level testing pyramids and there's like 10-level testing pyramids. Everybody's got their own version of how many layers there are.
How big is your pyramid?
Exactly. But down at the bottom is always unit testing, and then up at the top is something like GUI, right? So to go back to that Selenium example that I talked about, you're going through a whole bunch of different pieces.
Okay.
And generally speaking, the cost, as in how much time it takes to run the test, goes up the further up you go up the pyramid. So one of the strategies you're aiming for is to try to get the most amount of testing at the unit level as you can and get them as fast as possible. So if we were doing like an address form on a web page that had to do some validation when somebody types in the address and it has to double check, it has to do the right zip code, postal code, whatever, that kind of thing. One way to test it would be you could write all that in Selenium. But of course, if you're writing all that in Selenium, the test has to go all the way through the server to submit the page, go to the back end. The back end has to do whatever it's supposed to do and then come back out. So what you want instead is the logic that is responsible for that. You want the test as close to that as possible. So use tools like Selenium to test the GUI, but use the unit tests to test the business logic. And that tends to cause them to be the fastest operation, which is what you're aiming for.
Well, that's great. I think that takes us into projects this week.
Cool.
My project, I guess, is kind of related to testing in a way. It's about log files. It's a tool. I'm going to pronounce it Kelp, K-L-P. They spell it out as cool with a K, cool log parser. So I think they were headed toward Kelp in the first place. But it's a lightweight CLI viewer for log files. It's a project by Dirk Loss and a few other contributors. Again, it's a tool for understanding what's happening inside your structured logs, and it can analyze and isolate stuff. It allows for all kinds of formats. It mentions a handful: log, FMT, JSON lines, CSV, TSV, SQLite, whole bunch of others that are there. The ability to highlight key fields, timestamps, log levels and messages, advanced time analysis. You can basically track gaps in logs to figure out what's happening there, fuse bursts of events, filter by complex time ranges. There's a whole smart filtering area where you can kind of, again, look at time spans, but you also can develop your own Python expressions there and filter by the log level. Pattern searching, you can use grep in specified fields and show context lines. Visual insights, you can get your statistics and the number of events that are occurring at log levels, visually mark time gaps. A lot of things for readability inside there, color coding, per key display, expandable new lines, custom output templates, again, using Python expressions. So it looks like something where you can kind of build on top of this to improve your logging tools. Some interesting format conversions. So if it's coming in one particular format and you want to output it in another, a lot of the ones I just mentioned as far as input ones, it has those as output formats. And allowing you to transform unstructured logs into much more structured data if you need. The README is really good. I was impressed by that. Not only the instructions on installing, using pip or using, downloading it from GitHub and using the single file that's there. A really nice quick start, basic CLI commands for things like filtering by time, regex stuff, how to work with various formats, error handling. So if you're looking for some tools for logging, we've talked about this trend with GitHub repos that we are liking, that at the very end of the README includes this section. They're calling it complementary tools, which is kind of nice. So I'm saying like, okay, they're free, complementary, but also complementary that they go along with this topic and idea. General purpose data processing is one section, CSV processing, format conversion and viewing, TSV processing, and just generally like, hey, these are alternatives to what we're doing here. So I like that. I think that's a really handy thing to include here. So if you're going to work with logs in Python, I'm sure you're going to find something interesting here. It's quite the list. What's your project this week?
Well, we didn't do this on purpose, but my project this week is a library to help you test code that deals with dates and times. Sometimes things just work out.
Yeah.
So dates and times can actually be a tricky part of testing. So if your code is supposed to get the current date and time, your unit test is going to get a different answer each time the test gets run. Time moves forwards and all that. So
weird.
Enter FreezeGun by Steve Pullock. You may have heard of the mock library in Python. Mock allows you to dynamically override function calls and change their response. Typically, this is used for testing. The FreezeGun library is a wrapper to mock specifically for dates and times. It's pretty simple to use. You decorate a function or a method with the freeze time decorator, which takes a date or a date and time as a string. And then within the wrapped block, the date, time, now, and today calls essentially just return whatever you hard coded. It comes in a variety of flavors, so you can do it PyTest style on a Python unit test class, on a unit test method, as a context manager within your code. And it also supports time zones and is capable of using the dateutil library for parsing dates. So you can pass, January 14th, 1952 to FreezeGun, and it will turn that into an actual correct date time for the now. The other thing I had, which I thought was kind of cool, is it has a timer mechanism in it. So instead of just freezing time, you can reset to a point where your clock then starts. So if you're testing a code that, say, uses alarms where, the alarm's supposed to go off on January 14th, 1952 at 11 a.m., you can set it to 10:55 and then check 5 minutes later that it goes off. So that's kind of, it's an interesting sort of variation on just straight out mocking it. So mocking in unit tests is a really, really powerful tool. It can be kind of finicky if you've ever played with it to get it to work just right. And FreezeGun basically means you don't have to do it for one of the most common reasons you'd need to mock. So it's great that Steve has created this thing. It's very, very handy.
I've heard this name many a time over the last couple of years, so I'm excited to talk about it. All right. Well, thanks for bringing all these articles and projects and news this week again, Christopher.
Cheers.
All right. Talk to you soon. And don't forget, Postman is the world's leading API collaboration platform. And they just launched Postman AI, Agent Builder, the quickest way to build AI agents. Start building at postman.com/podcast/Python. I want to thank Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, Remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.